Well, so in math, we introduce some new objects that we call vectors. Vectors are new mathematical objects. Well, these objects, they have direction and they have magnitude. Okay, so that's the important part about these new objects. These objects are denoted by V, a bar on top of it as a vector, V, a bar on top of it, or just bolded letter V. So both of these representing these new mathematical objects that we call vector. These objects have direction and magnitude. Okay, very good. Very well. So where do I see these objects? Let's take a look at weather map. Let me show you how to visualize a weather map. This is a good example. So in this picture, we have weather map, and you see these little arrows that shows the direction of the weather in different geographic locations. So these are the things that we need, and we call these new objects vectors. As you can see, they have directions, and then we can define magnitudes or some numerical values to understand their behavior a little bit better. Again, one of the applications of these vectors is showing the weather map. Later on, if you're taking calculus class, you're going to see they're used in gravitational field, magnetic field, and so on. So let's go back to the board and start defining a very simple and easy vector. So suppose we want to define a simple vector. What are we going to do? We're going to start from the origin. Suppose our initial position is on the origin. Okay, so what do I mean by that? This is your xy plane, x-axis, y-axis, and this is the origin, 0 and 0. This is the origin, 0 and 0, or O. Well, what I'm going to do, I'm going to take a point. Let us take an ordered pair or a point in the plane. Well, it should be our terminal or stopping point. The terminal point. Like what? Like this point here. For example, I'm going to take 2 and 3. 2 and 3. Well, from the initial point going to the terminal point, it has a direction. I started from the origin and my stopping point is at 2, 3. My starting point at the origin O, and let's call this point like point P. 2, 3. This guy, this little guy that connecting the origin to P with given direction is a very simple vector. Here we just defined a new object, which is a vector. As you can see, it has a direction. It's going this way, all right? If I change the terminal point, I define a new vector, a new object. So you might be saying that, hey, you said we're going to define some new mathematical objects and they are denoted by V or bolded letter V. And then these objects, they have direction. I see the direction and the magnitude. How do I define the magnitude? First of all, this vector, let us call it vector V, is defined this way. Your vector V is equal to, well, here, in order to avoid any confusion between an ordered pair and a vector, we're going to use this symbol. Instead of using parentheses for a vector, I'm going to use this set of grouping representing the vector. The very first component is 2 minus 0, which is 2. The second component, the y component, is 3 minus 0, which is 3. This is my vector, guys. It's important to use the correct symbol. The magnitude or size or norm of the vector is denoted by, you're going to use two vertical lines, put your vector inside the vertical lines, and it's equal to the square root of your first component squared, 2 to the second, plus 3 to the second. 3 to the second. Okay, so we are going back to algebra, just doing some basic algebra here. The magnitude, the size, or norm of our vector is square root of 4 plus 9, or the magnitude of the vector is equal to square root of 13. This is my new object, and the length, size, magnitude, or norm of this object is square root of 13. Very good. So now let us talk about the abstract stuff. What are the formulas that we're going to use? So first of all, if we have 2 points, the initial point, the initial position, x1, y1. So this is your initial position. Let us call it A, x1, y1. The first coordinate is x1, the second coordinate is y1. So this is my initial point. And a terminal point. A terminal point, like what? Like B, x sub 2, y sub 2. Then we can construct a vector like this. Vector V defined with its components. Remember that, the symbol that we're using. It's going to be x2 minus x1, comma, y2 minus y1, and this is your vector. Okay. If we have 2 points, initial point and the terminal point, the difference between the terminal components and the initial coordinates, the terminal coordinates and the initial coordinates give you the vector components. So these are the components of your vector. x2 minus x1 and y2 minus y1. Components x2 minus x1 and y2 minus y1. Okay, so for example, if I give you the initial point as 2 and 3, the terminal point, like, I don't know, 1 and 5, you can say that, hey, this is my initial point and this is my terminal point. Vector v is going to be, well, x2, which is 1, minus x1, which is 2, comma, y2 is 5, and y1 is 3. This vector is -1 and 2. These are the components of my vector. -1 and 2. So this is my vector. What if I make a mistake and do the differences in the opposite direction? So if, note that, if you write it as, well, 2 minus 1 and 5 minus and 3 minus 5, you get this vector 1 and -2. What is the relation between these two? They are in opposite direction. Take a look at this. They are in opposite direction. This second vector is in the opposite direction of v. Okay. Take a look at this. We have x, we have y, 2 and 3, 2 and 3, initial point, my a, and b is 1 and 5, 1 and 5. This is my terminal point. Okay, so vector v starting from a going to b. This is my vector v. And this vector 1 and -2 is going to be in the opposite direction. This is -v. That's the difference between these two vectors. So please make sure when you're constructing your vector, you use the second coordinates first. Otherwise, you get a vector which is in the opposite direction and your answer is wrong. Okay, now for the magnitude. So when you constructed your vector using these 2 points, the norm, magnitude, or size, or length, magnitude is denoted by, so many books just use 2 vertical lines. Some other books use a different method representing the magnitude. Sometimes they use 2 vertical lines on the left, 2 vertical lines on the right, and the right vector v. And it means that you're finding the norm, length, size, or magnitude of your vector, which is denoted by square root of, well, the difference between x2, x1 to the second power, plus the difference between y2 and y1 to the second power. This is your magnitude. Very good. So now that we define a new object, how do we combine those objects? Well, do we have any mathematical method to add, subtract, multiply these new objects? So operations on vectors. Operations on the vectors. Well, the very first thing is that you can add vectors, addition. For example, if you have vector v, which is denoted by its components x1, y1, and another vector, the vector u, with its component x2, y2, you can take these two vectors and add them together. Addition. It's super simple. V plus u gives you a new vector. The very first component is x1 plus x2. The second component is y1 plus y2. Well, what else you can do? Of course, we can subtract two vectors. Subtraction. I can take these two vectors, find the difference between them. For example, v minus u, u minus v. These two vectors are different from each other. V minus u, well, it is x1 minus x2, comma, y1 minus y2. This guy is going to be x2 minus x1, y2 minus y1. The order is important. So addition, subtraction, a multiplication that we call a scalar multiplication. So we have three types of multiplications for vectors. The first one is called a scalar multiplication. What's the meaning of that? It means that we take a number, we take a constant, we take a scalar, and multiply that by any vector. For example, k as a number multiplied by v, it's going to give you k times x1, y1, x1, comma, y1, which is a new vector. The very first component is k times x1, comma, k times y1. This guy is called scalar multiplication. Scalar is just a number. Scalar multiplication. The scalar is k, any number. It can be 0, it can be 1, it can be 2, it can be 10, 1/9, any number. So this is scalar. K can be 0, can be 1, can be square root of 2, a third, -5, and so. You're just taking a number and multiply that number by the components of your vector. Scalar multiplication. So for multiplication, we have scalar multiplication. What else do we have? We have the dot product, inner product or dot product. Inner product or dot product. Well, what is this guy? What does it do? It takes two vectors and gives you a scalar. It takes vectors and give us scalar, a number. So do I have a formula for that? Yes, of course. Why not? The dot product between v and u is defined as, you write down first vector, x1, y1. You write down the second vector, x2, y2. You're multiplying the first components, x1, x2, plus y1, y2. So x1 times x2, x1, x2, plus y1, y2. This is the final answer.